Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Today we're diving deep into the world of garbage collection algorithms in Java. Victor, are you ready to talk trash?
Always ready for some garbage talk, Sheila. It's going to be a clean sweep of information today.
Before we get started, listeners, here's a quick quiz to ponder. In a high-throughput application, processing millions of transactions per second, which garbage collection algorithm would you choose and why? Think about that as we explore the topic.
That's an excellent question, Sheila. It really makes you think about the trade-offs between different GC algorithms and how they impact application performance. I'm excited to see what our listeners come up with.
Let's start with the basics. Victor, can you explain what garbage collection is and why it's crucial in Java?
Certainly, garbage collection, or GC for short, is Java's automatic memory management system. It identifies and removes objects that are no longer needed by the application, freeing up memory for reuse. This process is crucial because it prevents memory leaks and reduces the burden on developers to manually manage memory.
That's really helpful. Now, I understand there are different GC algorithms. Can you walk us through the main ones we'll be discussing today?
Absolutely. We'll be covering 4 main GC algorithms: serial, parallel, concurrent mark sweep, CMS, and garbage first, G1. Each of these algorithms has its own strengths and use cases.
Let's start with the serial GC. What can you tell us about it?
The serial GC is the simplest of the bunch. It uses a single thread for garbage collection and is designed for single-threaded environments or applications with small heaps. During collection, it completely stops the application, which is known as a stop-the-world pause. This means the application freezes briefly while garbage collection occurs.
That sounds straightforward, but I can imagine those pauses could be problematic in certain scenarios. How does the parallel GC improve on this?
Great observation, Sheila. The parallel GC, as the name suggests, uses multiple threads for garbage collection. This makes it more suitable for multi-core systems and larger heaps. While it still causes stop-the-world pauses, these pauses are typically shorter than with the serial GC because the work is divided among multiple threads.
I see. So it's faster, but still has those pause times. What about the concurrent mark sweep GC? That sounds like it might address the pause issue.
You're on the right track, Sheila. The CMS collector is designed to minimize pause times. It does most of its work concurrently with the application threads, which means less interruption to your application. However, it's more complex and can use more CPU resources than the previous two.
Interesting. And finally, we have the garbage first, or G1 collector. How does this one work?
G1 is the most advanced of these 4. It's designed for large heaps and aims to provide a good balance between pause times and throughput. G1 divides the heap into regions and focuses on collecting the regions with the most garbage first, hence the name. It can also do some of its work concurrently with the application.
That's a great overview, Victor. Now, I'm curious about how these algorithms have evolved over time. Can you give us a brief history?
Certainly, the serial GC was the original collector in Java. As multi-core processors became common, the parallel GC was introduced to take advantage of additional CPU resources. CMS came next, addressing the need for lower pause times in interactive applications. G1 was introduced in Java 7 and became the default in Java 9, representing the current state-of-the-art in balancing throughput and pause times.
That's fascinating to see how GC has evolved with hardware and application needs. Now let's talk about some real-world scenarios. When would you choose one algorithm over another?
Great question. For small applications or those running on single-core systems, the serial GC might still be a good choice due to its simplicity. For batch processing jobs where throughput is key, the parallel GC could be ideal. CMS shines in scenarios where responsiveness is crucial, like in user-facing applications. G1 is a good all-rounder, especially for large heaps and when you need a balance of good throughput and low pause times.
That makes sense. Are there any common misunderstandings or pitfalls people should be aware of when working with these GC algorithms?
Absolutely. One common misconception is that the newest or most complex algorithm is always the best choice. In reality, the best GC algorithm depends on your specific application needs and hardware. Another pitfall is neglecting to tune GC parameters, which can significantly impact performance. It's also important to remember that while G1 is the default in recent Java versions, it might not be the best choice for every application.
Those are great points, Victor. Before we wrap up, do you have any fun facts or interesting anecdotes about garbage collection?
Here's a fun one. The term garbage collection was coined by John McCarthy, the same person who invented the Lisp programming language back in 1959. Also, did you know that the study of garbage collection algorithms is sometimes jokingly referred to as garbology in the computer science community?
That's hilarious, Victor. Now, let's circle back to our quiz question. In a high-throughput application processing millions of transactions per second, which garbage collection algorithm would you choose and why?
Great question, Sheila. For a high-throughput application processing millions of transactions per second, the parallel GC would likely be the best choice. It's designed to maximize throughput, which is crucial in this scenario. While G1 might seem tempting due to its balanced approach, for pure throughput, parallel GC often performs better. However, if the application also has stringent latency requirements, G1 might be worth considering. As always, the best approach is to test different algorithms with your specific application and workload.
Excellent explanation, Victor. To summarize today's episode, we've covered 4 main garbage collection algorithms in Java: serial, parallel, CMS, and G1. We've discussed their evolution, strengths, and use cases. Remember, the choice of GC algorithm can significantly impact your application's performance, so it's crucial to understand these options and choose the one that best fits your needs.
Absolutely, Sheila. And don't forget to tune your GC parameters for optimal performance.
Great point, Victor. In our next episode, we'll be diving into GC tuning and monitoring, so stay tuned for that. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth content on Java internals. Until next time, happy coding.